Before I show you the slope field for 7a, I want you to pause the video and do it yourself. Okay, so now that you're back, when x is 0, I get a horizontal slope. When y is 0, so all along the x-axis, it's undefined. When they're both 1, it'll be a negative 1. When they're opposite in signs, it'll be a positive 1. And again, same signs, it'll be a negative 1. And so now when I'm ready to solve the differential, of course I'm going to need to move y over, and I'm going to need to move dx over. So I'm going to have y dy and negative x dx. And now when I integrate, I'll have y squared over 2 and negative x squared over 2. We'll put the plus c over here on the x side. And then if I want to get y by itself, which I do, I'll multiply everything by 2. So I have y squared. Now remember, when I multiply the constant by 2, it's still just a constant. And my final step, getting y by itself, is I'll have to take the square root. So I'll have plus or minus, and I could rewrite it in a different orders because of the subtraction. So there's my final equation. Okay, before I do problem 8, again, I want you to pause the video and see how far you can get by yourself. So, since I know it's a growth problem, I'm using my formula for growth, population growth, that is. That's an ugly K. Oops. And I have two pieces of information. 180 flies after the second day, so it looks like time is in days. So when time is 2, the number of flies is 180. And when time is 4, y is 300. So I'm going to start with the first one. And if I plug that in, I'll have 180 equals c e to the 2k. And normally I would solve for c first, so if I solve for c, it looks like this. And now that I have c, I would plug in the second clue. Ooh, I feel like blue on Blue's Clues. So I would have 300, because that's going in for y, and now I know c, sort of, and e, now it's to the 4k, and of course this same base, these are going to reduce, so I'll have 300 equals 180 e to the 2k. That's a 180. Yuck. I'll fix it. Looks horrible. And so now I want to isolate the k. So first I'll get rid of the 180. So I have e to the 2k equals, I think it's 5/3 divided by 60. And then if I want to get the k down out of the exponent, I'll have to natural log. So I'm going to have natural log of 5/3 equals 2k, because the natural log of e is just 1. And then I'll divide by 2. So k equals natural log of 5/3 all over 2. And now substituting that back in, I'm going to use this version. So I have 180 over e to the 2, and now it's going to be natural log of 5/3 over 2 is my c value, and that pair of 2's at least will cancel. So I'm going to have 180 over e to the natural log of 5/3. So my original equation is y equals 180 over e to the natural log of 5/3. Oh, I didn't even notice that's going to magically cancel out too. And then times e, and k is natural log of 5/3 over 2. Oh, this is going to simplify a lot. So down here on bottom, this is going to turn into just 5/3. And this is really e, and we could call it 1/2 natural log of 5/3. And of course, I can reduce this really ugly fraction to 108. Now, I cannot put this back up. Do not think you can, because the t is sitting there. He's blocking it. So I have to leave it like so. And then when it says how many were in the original population, well, I just figured out when t is 0, this entire second piece, of course, will be e to the 0, which is 1. So I'll have y equals 108 times 1, which is 108. So in the original population was 108 flies.